students. In this class, we will be doing class 10 matriculation syllabus or Samachir Kalvi syllabus. We are doing first chapter, that is relations and functions. Already few exercises I have completed. Now we will see the next topic. So the next topic is representation of functions. Okay, in relations and functions, that is in the first chapter. This is a subdivision, representation of functions. So how can we represent a function? So we can represent a function in 4 different ways. So what are the 4 different ways? One is set of ordered pairs. In a set of ordered pairs, we can represent a function. Then in a tabular form, we can represent a function. Through an arrow diagram, we can represent a function. And through graphical representation, we can represent function. Okay, so a function may be represented by a set of ordered pairs, a table form, an arrow diagram, a graphical form. So in these 4 different ways, we can represent a function. Okay, when we come to this graphical form, every function can be represented by a curve in a graph. So when we plot the ordered pairs in the graph, when we are joining it, that joining line, we will say it as curve. Okay, so every function can be represented by a curve in a graph. Okay, so for this one, when we represent a line, when we represent a curve on the graph, how to check that whether it is a function or not? For that, we will do vertical line test. That is, a curve drawn in a graph represents a function. Okay, so for that a condition is there. If every vertical line intersects the curve in at most one point. So we will use this vertical line test to check whether the curve is a function or not, whether the given graph represents a function or not. So for that, we will use this vertical line test. See this example. So this is a graph. So 4 different graphs I have drawn. In this is a graph. This curve is a graph. When we do this vertical line test, vertical line touches the given graph at 2 different points. So first one is that vertical line touches the graph at 2 different points. The same way, if you see this one, this third example, this curve, this is a curve we got. Whatever ordered pairs are there, that we have plotted it and we have combined it to a curve. So that curve, when we cut through a vertical line, at 2 points, it touches the graph. So these 2 graphs does not represent a function. Since through the vertical line test, we are telling that it touches the graph, that vertical line touches the graph at 2 different points. So these 2 examples. So when we do a sum, we are getting like this. At 2 different points, the curve touches the vertical line. That is not a function. That curve represents, that is not a function, we will say. Okay, so that curve is not a function. Okay, so that curve is not a function. Curve does not represent a function. Then, if you see these 2 examples, through the vertical line test, if we are doing, at only 1 point it touches that vertical line, at 1 point only it touches the curve. So this represents a function. Same way this graph also. So this is a curve, we will say. In that, through the vertical line test, when we do, at 1 point only it touches that graph. So these 2 examples, the graph represent a function. These 2 graphs, when we are getting graphs like this, that does not represent a function. So based on those representation of functions, we will be doing exercise sums. So exercise 1.4. First sum is determine whether the graph given below represent functions. Give reason for your answer concerning each graph. So as I told you in the previous explanation, that with the help of that vertical line test, we can check that whether the given graph is a function or not. So First graph is like this. So when we put the vertical line here, at 2 points it touches the graph. It touches the curve at 2 different points. So it is not a function. Since it touches, so that is the reason we are going to give. Since it touches the graph at 2 distinct points, 2 different points, it is not a function. Okay, then second sub is a graph is drawn like this. The vertical line test I am doing. So at 1 point only it touches the graph. Since it touches the vertical line touches the graph at 1 point, it is a function. It is a function. So this is the reason for that. Okay, this one. When you take this graph, it is like this. This is a we got a curve like this in the given question. So when you draw a vertical line here, at 2 different points, it touches the 2 or more points, it touches the graph. So it is not a function. So it is not a function. Okay, then next one is this graph. So for this one, when you draw a vertical line, at 1 point only it touches the graph. So it is a function. So through this vertical line test, if a curve is given, we can easily identify that whether it is a function or not. Second sum is let f is equal f such that a belongs to b a function defined by f of x is equal to x by 2 minus 1, where a and b set is given. Function is given as x by 2 minus 1. Okay, represent f by these 4 different things we are asked to represent. One is set of ordered pairs, a table, an arrow diagram and a graph. So here it is given f of x is equal to x by 2 minus 1. So if we take x value as 2, that is from the first set if we take f of 2 is equal to 2 by 2 minus 1. This is equal to 1 minus 1 is equal to 0. Then if x is equal to 4, f of 4 is equal to 4 by 2 minus 1. This is 2 minus 1, that is equal to 1. Then x is equal to 6. Then f of 6 is equal to 6 by 2 minus 1, that is 3 minus 1, 2. Then x is equal to 10. Then f of 10 is equal to 10 by 2 minus 1. So that is 5 minus 1, 4. Then x is equal to 12. So f of 12 is equal to 12 by 2 minus 1, that is 6 minus 1, that is equal to 5. So when we take these values of x, we are getting the function, that is the elements are 0, 1, 2, 3, 4, 1, 2, 4 and 5 we are getting. Okay, 0, 1, 2, 4 and 5 we got. Now all these things to be represented in these 4 sets. So first one is set of ordered pairs. So how can we represent this? If we are having the value as 2, the function for this is 1. So it is 0. First one, if we are substituting x value as 2, we will get 0. So we will write the ordered pair as 2, 0. Then next one is 4, 1. So 4 and 1. Then next one is 6, 2. 6, 2. Then 10, 4. 10, 4. Then 12, 5. 12, 5. So like this you will represent the given function in the ordered pairs. Then the second one is a table. So we are going to represent it in a table. If x value is these things, we will get 4 functions, 4 f of x for that x and f of x. So if x value is 2, f of x is 0. Like this, if it is 4, f of x is 1. If x value is 6, f of x is 2. If x value is 10, f of x is 4. If x value is 12, f of x is 5. So we represented that in the tabular form. Arrow diagram will represent. So two sets are there, set A and set B. Okay, so in this elements are there 2, 4, 6, 10 and 12. These are the elements of A, and elements of B is 0, 1, 2, 4, 5, 9. So when it is connected with a function, 2 and 0 is connected with a function 4 and 1, 6 and 2, 10 and 4, 12 and 5. So you will get a function when we connect this A and B, with some function, with this function x by 2 minus 1, these two numbers are connected. Then the next one is graph. So we will represent that in the graph. The same ordered pairs. Since it is in the multiples of 2, I will take the units as 2, 4, 6, 8, 10. And here I will take it as 1, 2, 3, 4, 5. So here 2, 0. So this one is represented in the ordered pairs, and that I am plotting it here. So this one is 2, 1. Then 2, 0. First one is 2, 0. So the 2, 0 point will be here. Then next one is 4, 1. Next one is 4, 1. So this point is 4, 1. This point is 2, 0. Then next one is 6, 2. 6, 2. Next point is 6, 2. Then 10, 4. 10, 4. 10, 4. Next one is 12. 12, 5. 12, 5. 12, 5 will be, point will be here. So this is 12, 5. So this one I will join. So this is the graph for the given set of ordered pairs for the given question. This will be the graph. Okay, so in this 4 different ways we have represented the given function. So with this I am completing today's class. The remaining sums I will do it in the next class. Whatever doubts you have, you message me in the comment box. Thank you.